Hello friends, myself Professor Rajendra Baburao Garse, HOD Electrical Engineering Department at NB Navle Sinhagad College of Engineering Solapur. I am having total teaching experience of 9 years. I have completed BE Electrical from Government College of Engineering Karad and MTech from Indian Institute of Science Bangalore. I have secured All India 7th rank in the GATE examination with a percentile of 99.96. In my last video, we have discussed about single phase half bridge inverter with RL load. We have done the detailed analysis, detailed output voltage, output current, harmonics which are present in the output voltage waveform as well as output current waveform. Today we are going to discuss about single phase full bridge inverter. The difference between the single phase half bridge and the single phase full bridge inverter is, in the single phase half bridge inverter we were having 2 switches and 2 diodes. In the single phase full bridge inverter we are going to discuss the circuitry which is having 4 switches and 4 diodes, right? The drawback of single phase half bridge inverter is it requires a specially designed 3-wire DC supply, right, which is not economical, right? Next, so let us discuss the single phase full bridge inverter, right? Single phase full bridge inverter with purely resistive load. So here it is a circuitry for single phase full bridge inverter. As this is the inverter, definitely the input is this is the EDC. We are using 4 switches, S1, S2, S3 and here it is S4, right? Across each switch the diode is connected in anti-parallel, right? Across S1 diode D1 is connected, across S2 D2 is connected, across S3 D3 is connected, across S4 D4 is connected. And here we consider the load is purely resistive, right? The voltage across the load is considered to be positive if the polarity is higher here and lower here. The direction of the current is shown is from left to right, means the current I0 is considered to be positive if the direction is from left to right. Okay, current flowing through the switches are IS1, IS2, IS3, IS4 respectively. Current flowing through the diodes D1, D2, D3, D4 are ID1, ID2, ID3 and ID4 respectively, right? The switches are nothing but, it may be a BJT, it may be a MOSFET, it may be IGBT, it may be GTO, it may be SCR, right? But most preferably for inverter circuitry the MOSFETs are used, right? Because the MOSFETs are the switches which are having the highest switching rate. Okay, so let us discuss the operation. Okay, next, so our task is to convert DC to AC. So what is the expected output? Yes, voltage across the load should be a AC, right? Means it should be a sinusoidal one, right? And now we are going to discuss whether we are getting the sinusoidal output across the load or not. Okay, next, so at time t is equal to 0, right? The waveforms we are having V0, I0, IS, IS1 and IS2. IS is nothing but the waveform for the current flowing through the supply or supply current, IS. This is the IS, right? Next, so at time t is equal to 0, switches S1 and S2 are turned on. So at t is equal to 0, S1 and S2 are turned on. So current will flow from EDC, S1 load, S2 and again back to the EDC. Means in this loop the current will flow, right? So what is the voltage V0? Yes, it is like plus apply KVL, plus EDC minus voltage across switch is 0 minus V0 minus voltage across switch is 0, right? So is equal to 0. So it is plus EDC minus V0 is equal to 0. So what is V0? V0 is equal to EDC, right? What is I0? According to Ohm's law, I0 is equal to V0 by R. So what is I0? I0 is equal to EDC by R. So from t is equal to 0 to t is equal to t by 2. So from t is equal to 0 to t by 2. Yes, V0 is EDC, V0 is EDC, t is equal to 0 to t is equal to t by 2, V0 is EDC. What is I0? I0 is EDC by R, right? Which two switches should be in the on state? S1 and S2. So that's why IS1 and IS2 will be same as that of the load current. So IS1 IS2 will be same as that of the load current. This magnitude is same as that of the load current, that is EDC by R. This magnitude is EDC by R. Next, IS will be same as that of the IS1 and IS2, right? IS1 and IS2. Next, this will continue till T by 2. At T by 2, switches S3 and S4 are turned on. S3 and S4 are turned on. So current will flow from EDC, S3, load, S4, and again back to the EDC. The current will flow like this, right? Now if you check the direction of the current flowing through the load is from right to left. So the current is negative now, right? When S1 S2 are in the on state, the current is from right to left, right? When S3 S4 are in the on state, current direction is reversed. So I0 will be negative. Okay. Next, can we apply KVL for finding the V0? Yes, it is plus EDC plus V0 is equal to 0, right? So what is V0? Plus EDC plus V0 is 0. So what is V0? V0 is minus EDC, right? So after T by 2 to T, when S3 S4 are in the on state, at that time what is I0? I0 is equal to minus EDC by R. And what is the V0? V0 is equal to minus EDC, right? Next, but what is the IS? What is the IS direction? Whether IS is same or it is reversed? No, when S3 S4 are in the on state, current IS will be in this direction only, right? S1 S2 are in the on state, again the direction of the current IS will be same, right? IS3 IS4 will be same as that of the I0, that is EDC by R, right? EDC by R. IS3 IS4 is EDC by R. What about the IS1 IS2? IS1 IS2 are 0 because these two switches are in the off state. Again, after T is equal to T, till T is equal to 3T by 2, right? 3T by 2 means at this instant, till this instant, right? So switches again S1 S2 are in the on state, and again the same cycle goes on repeating. Okay. So next, one more thing here, for the purely resistive load, right? As we know, the resistor is the element which only absorbs the power, which only consumes the power, right? It will not store the power, right? Or the energy. Okay. So that's why when S1 S2 are in the on state, output voltage will be plus EDC. S3 S4 in the on state, output voltage will be minus EDC. Okay. So from 0 to T by 2 we are turning on S1 S2. T by 2 to T we are turning off S1 S2 and again turning on S3 S4, and same goes on repeating. Now whether it is a AC voltage, it is having a positive value, negative value, positive value and negative value. That's why the output voltage is AC. Okay. But whether it is a sinusoidal one, no, means it consists of harmonics. Okay. So we are going to derive the Fourier series analysis later on. Okay. Next, what is the V0 RMS? Can we write the expression for V0 RMS? So before that, whether there is any functioning of the diode for purely resistive load? No, right? Because when load is resistive, 0 to T by 2, S1 S2 are in the on state, so diodes are in the off state. Okay. When T by 2, T is equal to T by 2 to T, S3 S4 are in the on state, at that time also again diodes will be in the off state. Okay. So that's why there will not be any operation of the diode. Okay. Next, let us derive the expression for the V0 RMS. Okay. So V0 RMS is equal to 1 by T, right? Integration from, if you check the waveform of V0, whether V0 is a periodic signal, yes, the period is what, 0 to T, right? So capital T is the period of the signal, right? Whatever the waveform from 0 to T, same is repeating from T to 2T, same will repeat from 2T to 3T, right? So that's why the period is T. Again it is divided from 0 to T is divided as 0 to T by 2, T by 2 to T. So we can write it as RMS means root mean square, that is the square root of mean of squared value. So this can be written as V0 RMS is equal to 1 by T integration from 0 as 0 to T by 2, T by 2 to capital T. Okay. Next, so what is the value of V0 during 0 to T by 2? It is a plus EDC, so square is EDC square, right? T by 2 to T, it is a minus EDC. What is the square of minus EDC? So again it is a plus EDC square, right? So square root of mean of squared values. So it is square root of mean of squared values, right? So it is, after simplifying it, yes, we can get EDC common. So it is taking outside of the square root. So it is EDC by root T into putting the limits T by 2, T by 2. So it will be V0 RMS is equal to EDC, right? RMS value of output voltage is equal to EDC. If you compare this V0 RMS with RMS value of the output voltage for purely resistive load in single phase half bridge inverter, yes, it is a 2 times that of the single phase half bridge inverter, because there we were having a pulse of EDC by 2, and here it is we are having a pulse of EDC. Okay, so this is about the single phase half bridge inverter with purely resistive load. Okay, so in my next video we will discuss about the Fourier series analysis of single phase half bridge inverter. Okay, thanks for watching.